My presentation is focused on security issues in GSM network. So maybe the first, as an introduction, we published several papers on this topic, and the last one will be presented next week in Baltimore. And as well, we prepared a chapter in book in Springer, unconventional method and in field of security. So I'm co-editor of this book, and there will be several chapters. So my colleague from Italy, Dr. Fazio, will contribute to this book, and I will present the topic which has been solved at our university, in our department, and was a part of diploma thesis as well. So the brief description of realized attacks, we prepared and realized three types of attacks in GSM network. You know, GSM is quite old technology. It's the second generation. The third one is UMTS, and the last one LTE. And tomorrow will be presentation on 5G. Yes, so it means the next generation, which will appear in next 5 years. So the GSM is quite old, and it's a question of an issue of time when this technology will be switched off. Yeah. But nobody is brave enough to do that, because in this technology, in the world, there is maybe several billion users of this technology, and several billions mobile phones supporting GSM and not supporting the newer technology. So we realized three attacks. The first attack was based on the implementation of fake GSM base station. So we deployed false GSM station in our university campus, and of course only in our laboratory, in our building, so we couldn't affect the traffic outside. And we pretended that this GSM station is official, and we succeeded, and the mobile phones were registered with this GSM base station. Even questions to our rector office was sent from students. What does it mean VSBnet when when it appeared at their mobile phones, students, which were close to this BTS stations, because our student, one diploma, solving the diploma thesis, decided to take these base stations and to move two students to dormitory. Yeah. Then the many students were surprised that there is a new operator, and I had to explain this issue in the rector office, that it is not official VSB network, but it's only experiment. Okay, so it was the first attack. The second one, it's very cheap, and it's eavesdropping. The first one, fake GSM base station, it wasn't expensive. We need a FPGA, programmable logic array, and we applied standard USRP from ETAS research or from National Instruments. It is similar, but with double price. Yeah. And some series, but from ETAS research. The ETAS research was the first company which decided to produce these USRP modules, and in this USRP it's possible to deploy the GSM Open BTS or Open LTE. There will be presentation about LTE after my presentation. So the price was about $1,000 for these models. $1,000, the antennas, then some box and so on. Yeah, so the total price is not so high to build our GSM station. Yeah? And you can tune, because there is a software, radio-defined radio SDR, so you can tune the frequencies between, in our base station, between 40 megahertz up to 4.5 gigahertz. Yeah? Now in Czech Republic, the following frequencies are used: 700 megahertz for LTE, then 800, 900 megahertz, 1.8 gigahertz, 2.1 gigahertz for UMTS, and 2.6 gigahertz only for LTE. So these frequencies are used in Czech Republic. So our BTS, our USRP covered all frequencies which can be used in Czech Republic. The second attack was the taping of communication in GSM network, and was realized with simple DVB-T tuner, USB. The price is several hundred crowns. Yeah? So several $10 we can buy such a DVB tuner, and then you have the right chipset, because it must be a Realtek 82 and some number, and we use the chipset with the tuning between 35 megahertz up to 1.1 gigahertz, so we covered only GSM, yeah, 800, 900 megahertz. So, and then we adopted this tool, RTL SDR, which was developed within Osmocom project. So, it's possible to take SMS and voice calls as well, and then to decrypt this SMS and voice call, because it was a little bit complicated, but it's feasible. Yeah. We decided to catch only SMS and speech which weren't encrypted. Yeah. So it was simple for us. It's possible. I will explain how to do that. And the last attack is attack on IMSI. So it's IMSI, maybe you know, it's International Mobile Subscriber Identity, because in mobile phone you can find the following information. Email, you know, the email is connected with the hardware phone. Then there is a IMSI. The IMSI is very important information, because the IMSI is a unique identifier of mobile subscriber in mobile network. And it's a secret information. So it is the reason why the IMSI is replaced by temporarily mobile subscriber identity, yeah, TIMSI. And this TIMSI is valid in some location area, and if you change this location area, you will receive the new TIMSI. But the IMSI is secret, and IMSI is discovered only in case of registration. So, if you have an IMSI and key, then you are able to decrypt SMS or speech. And for example, there is a tool, SimSpy, yeah, in written in Python, when it's possible to get this information, the key and IMSI. Yeah. And of course, if you have the mobile phone in your hand, yeah, then you are able to dial some code, and you will get the IMSI as well displayed on the phone. Yeah. But it's an interesting question, how to get the IMSI. So to push the mobile phone to make it a registration, it's not easy. Or to get a TIMSI this way, then you will send a corrupted SMS. The SMS is not displayed because there is a mistake in this SMS, but you will get the TIMSI because you will initialize the communication on this mobile station. So okay, so I will explain how to get this secret information. What is disadvantage that if you make a false BTS, if you get an IMSI, then there is made a new registration, and the communication communication failed. Yeah? So because there is a new registration to your BTS station, so it means that subscriber can notice that there is some new registration and a new network, or you can pretend that it is the same network. So I will explain maybe the structure of GSM network. So very briefly, I think that there is nothing to explain because you know it from our department and from our courses. So basic stations, then you have then the control of this area, yes, BSC. Then there is a mobile switching center. It's like a phone exchange, like an exchange, telephone exchange, switching system. And of course the gateway of MSC if you need to ensure you need to have a connection to ESDN, ISDN, or some peering, so you need the gateway. If you need the data communication, there is necessary to implement GSM. Yeah, it's the next component, and there is a very nice project, OpenGSM, but we haven't tested this project yet. So, and of course, there are databases like visitor location register, home location register, then the authentication for the authentication and operation center, maintenance center, and regular center. So these components are parts of GSM network. As regards this IMSI catcher, the IMSI catcher is just the application. So this application can be run in your system, and then if you create a false BTS, I can locate this BTS here, and everyone who comes to this room can be affected of this BTS. The first time it was presented in 2010 in Berlin, in a conference, Chaos conference, and there is a video on YouTube, you can find it, and it's incredible. Yeah? And it was very successful because the people came to this room, their phones were registered with fake BTS, and then the presenter told him after the presentation that their phones are registered with his basic station, which was located in a corner of this conference room. Yeah. It's recorded, and it's you can find it on YouTube, and it was very nice. So this way we are able, if we build our own BTS, what we are able to do because there is an open BTS project in USRP, and then we are able to catch the IMSI which are around. What is necessary to do? Every BTS sends a list of neighboring basic transceiver stations around. So we get a list of these stations around, and you can see the list that there is a cell ID, location, area code, and this code, absolute radio frequency channel number, which is very important. And you can see the list of 5 these base stations, and we take the base station with the lower level of signal. So we take the identification of this base station, we configure in our open BTS, so it means that we set some information about location, area code, and so on, and then we restart the open BTS, and you can see there is a new base station with a new cell ID, but the same code and the same ARFCN, but the higher signal strength. So the higher receiving signal strength. So it means that the mobile phone is going to be registered with this open BTS, and this way we get IMSI. It's IMSI. Yeah. And if we have this IMSI, we can count how many mobile phones went through the subframe door, or, for example, this identification is unique, so you can monitor the movement of people with these mobile stations. So this advantage is that these users can notice and can observe that their mobile phone were registered to the different BTS. No. So it's if we pretend that we are the same operator, it's a little bit complicated. But they can find that the established call was discovered. Yeah. So was terminated because there is a required the new registration. So it's only one notice that it is disadvantage. Okay, so and you can see in our open BTS there is a list of temporarily mobile subscriber identity. It's not important, so it's only our list. But you can see the IMSI which were called from mobile stations, from real SIM cards. And finally, I have to warn you that the operation of IMSI catcher in Czech Republic and most other countries is illegal. So it's a question for some intelligence services and so on. Yeah, we tested it only in our laboratories because it is the field of our study, mobile networks. So the second topic was active taping false BTS. So the idea is following: if we are able to build a BTS base station, then we can pretend that we are real operator, like a O2 or T-Mobile, and mobile phones are registered to our BTS. And if someone makes a call, then we are able to provide this service, and we will establish this call. So this call is realized, and then we record everything what happens. So it is ideal. So it means that the disadvantage of this solution, you can see that the ciphering is switched off, because A5 0, it means that ciphering is switched off. Of course, we need our favorite software asterisk and the function in diaplan monitor, and we can record the performed calls. Yeah. The little bit problem with this incoming traffic. Outgoing traffic is without problem. We are able to provide the service, and to record every call. But the problem with this incoming calls, but it's possible to do that, because if we are able to forward the traffic to the new destination, then it could be realized. But in our test, we tested only this outgoing call. So the first BTS, an active taping the part of this BTS subscriber register, of course, it's the module with functionality of home location register and modified in SIP registry. What is new that the last year there was created a script which is able to cooperate with IMSI catcher, and if the new IMSI is identified, then this IMSI is automatically written in database, and there is no action is required from mobile phone. If you are experienced with OpenBTS, you know that then you have to send some SMS to create a new account, yeah? To write this IMSI to database. But with script which was created last year, it's done automatically. It was a part of diploma thesis. The student was Ladislav Behani. Yeah, he delivered his thesis last year, and this script is part of his thesis. Okay. So we can see the final configuration of BTS. 230 is the country code for Czech Republic. It's a subspecial code for mobile networks, and network code is 02. It's 02 for T-Mobile, 01 for Vodafone, 03 for 04 is for UFON, and 99 is some testing operator in Czech Technical University. There is a radio RDC, a radio research center in Czech Technical University. Okay, so and finally passive taping with this RTL SDR tool, Osmocom. It was applied with DVB tuner and AirPro tool, which is able to export the speech as audio file, GSM audio file. You can play back this file in VLC and listen what happens in network, mobile network. Our test was made under the following condition, that we had our own BTS. It wasn't a real BTS, it was our own BTS, mobile station somewhere in network, and the encryption was switched off. But it's possible to do with encryption as well, because if the appropriate coding is used, A51, A52, A53. Unfortunately, with A8 it's not possible. Yeah. But the operators used mostly the old encryption standards, because these encryption standards are compatible with any mobile phones. Yeah. With any mobile phones. So you can see that there was the SMS test, testovací SMS zpráva, so we recorded. First time these attacks were demonstrated in 2010 by Karsten Noll in this conference. Our contribution that we are able to demonstrate these attacks as well with the new devices, with DVB-T from Osmocom project, with USRP, which we have in our laboratory. So, it's all. And now, if you have questions to me, a question? If not, thank you. And now we will continue with the next presentation on OpenNFT. So the legal application of these tools, of course, it's a little bit problem. And now there will be demonstration of OpenLTE and